So, you guys were trying to hopefully plug into that equation that we talked about yesterday. Get you a little higher. Let's use a red pen. How does that equation go for a general sinusoidal curve? Plus this week times. Now there are a couple different variations, but that's one. There are a couple different variations, but that's one. Now, as you guys were looking at number 79, you were trying to do things. So, for instance, what did you guys figure out was your D? D. 0. Okay, hold on. You've had a few minutes to work on this, right? You put graphs in your calculators, right? Okay, and we see the letters I'm looking for, right? Cool. So why does D have to be 0? It's centered around the x-axis, and if you look at it, how high up does it go? How low does it go? What's the middle? 0. Plus, what's the amplitude? Oh, we just... Now, it gets to be a little bit trickier. I think, just like in our graph, I think it's easier to go to the initial point and then come back. Just like graphing, 1, 2, and 4. Where did you guys decide to put your initial? Pi over 4? How'd you figure that one out?
That's pi.
Yeah, if that's pi over 2, and where does this seem to fall? Okay, so we kind of had to guesstimate just a little bit. But if that's pi, we are going by pi over 2s, and it seems to be about halfway. And if you look, the next key number is pretty stinking halfway, right? Doesn't look like 2/3, doesn't look like 1/6. It seems pretty halfway. So yeah, I would agree with you there with pi over 4. And cosine needs to start at the top. At the top, right? Now, could you have maybe come over here and made an argument for whoever this guy is? There are going to be all kinds of tops. So you could have made an argument for pi over 2, pi, 3 pi over 2. Ooh, wouldn't that be 7 pi over 4? Because it's right before 2 pi. You could have made an argument for negative 7 pi over 4, but what do you think I'd rather have? The one that's way far away or the one that's way close? So if we have to choose the one that's way close. So therefore, to the right, pi over 4 would be minus pi over 4. And now you need to think about period. That's not what goes in this spot. This spot is B. But doesn't B come from the period? Because the period equals 2 pi over B. So if I'm able to find the period, then I could find B. So my question is, how long, how far from... Oh, we just marked that. How long, how far from beginning to end? Well, we just said this is pi over 4-ish, right? Couldn't we count by pi over 2s, the tick marks? And we'd have to go halfway in between, but there's 1 pi over 2, 1/2, 1 whole, 1.5, 2 whole. 2 whole what? So if 2 pi equals 2 pi over b, what must b equal? 1. I could multiply and divide by 2 pi, and 2 pi over 2 pi is just 1. Dun, 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 dun. Could you write it prettier, just to be something like 2 cosine of x minus pi over 4? Yeah, you could. You could. If you plug that into your calculator, did you? Now, number 83 gave you hints not with a graph. I know like the hardest one in homework. It was just an example of one. Number 83. Okay. Maybe it's a little easier to plug in, except this time we're not plugging into a cosine one. This time we're plugging into a sine one. All right. What can we plug in? Maybe we should go step by step like we did the last one. Did anybody find a hint in there somewhere that has to tell us about D? Vertical translation. So it, since the middle did, up 1. Oh, That is vertical translation. Amplitude, any ideas? Ah, that one's easy. They told us. They told us to use a sine curve. Cool. Remember what I told you to look for next? It says right, so minus pi over 2. Period, O, set equal to P, pi, equals 2 pi. See what I did there? B in the period formula. So period of pi, which equals pi over B. Some of you might think, oh, pi, that's a half of 2 pi. Cool. Some of you guys might think, I have no idea, let me solve the formula. Okay, so wouldn't we multiply by B? And then wouldn't we divide by pi? At 2, I thought it was 1/2. Oh, horizontal dilations. Flip. Horizontal dilations. 2 pi to become pi will be a horizontal factor of 1/2, which means the original constant coefficient is 2. Gavin, go ahead, bud. Yes. Yes. Here's a... Well, this could have also... see how I can explain this. Pi over 2 could have come from... Does that make sense? So even though this is what you see, I mean where it came, you have outside. Yeah. So be careful of the reducing thing. Be careful of the reducing thing. What Gavin saw was C over B. C is pi and B is 2. That's one. The ratios are going to be the same, but it could have come from a larger set of numbers, so you have to be careful. Okay, with that, let's go ahead and check homework. We're going to go pretty quick with the evens. I'm going to go over questions on the odds, especially. I think I have the homework up and ready. Yeah, I do. As we're going through grading evens, you guys keep a lookout, keep an eye out for question marks on the odds that you know you already have a question on that you need to see. 2 extra credit problems. What? Number 4, vertical translation. Number 12, you guys can see both the period, which they had to take the coefficient 2 over 3. You needed the entire coefficient. This could have been rewritten negative cosine of 2/3 x. Remember, it's the same thing. So my b was 2/3, hence why 2 over 2/3 is the same thing as 2 pi times 3 over 2. That's how we ended up with 3 pi. Amplitude is always, always, always positive. Negative reflection. So hopefully number 8, you guys caught the same thing. Pi over 10 is my b. So I have to do 2 pi times 10 over pi. This is where I like this formula of 2 pi over b, but I don't. I like the formula of 2 pi over b, but I don't. Because sometimes the 1 over b times 2 pi is nicer, because you could have taken the pi over b times 2 pi instead of the 2 pi over b when you have a nasty b. Because then you can just take the reciprocal and then multiply. But both ways end up working, getting you 20. Amplitude is 2/3. And number 20 says, hey, if you just shift. Oh, that was just a typo. Sorry, ignore the F. I think I just crossed it out because it was a typo. Left pi. Just from what we're used to with addition of a number inside the parentheses. That's horizontal shift. Backwards what you think to the left. Now it got fun. 34 actually had you guys doing quite a few things, right? if I remember right. That's going to be way too much. Wish there was like a 120 option. Okay. Let's just see if you guys got your clues okay. Sinusoidal axis was at 0, d equals 0. Amplitude is 2. Period 2 pi over b is 2 pi over 2. So it had to complete every pi. It got squished in a little bit. They went ahead and identified and actually wrote out each of their 5 key points. You might have just put the 5 key points and stopped with that for the first one. And they were actually graphing 2 functions in one graph and trying to compare the 2. They were taking 2 functions in one graph and comparing the 2. So the first curve you can see goes up 2, down 2, no horizontal shift, so it starts at a maximum, or it starts at an initial point of 0, 2. Top, middle, bottom, middle, top. Your quarter cycles are 1/4 pi, so go over 1/4 pi, go over 1/4 pi, go over 1/4 pi, go over 1/4 pi. That's the first curve. The second curve, if you were just graphing him on his own, his period's going to be 1/2 pi. He got squished even more because it's 2 pi over 4, or 1/2 pi. And he's a cosine that starts down, but he only goes up 1 and -1. If you see him, he goes up 1. He starts down. That reflection that we saw yesterday, he starts down, not up for his initial point. So his initial point is 0, -1. And then going by quarter cycles, of pi over 2 is pi over 8. So pi over 8 and another pi over 8, that's pi over 4, another pi over 8, another pi over 8, that's pi. Another pi over 8. But if you compare the two, well, this guy is half the height of that guy. Sorry, this guy is half the height of that guy. And they kind of wrote it as a function, but he's half the height of that guy. He's vertically reflected because he got flipped down. And he got horizontally shrunk. He's half as narrow. Or he completes twice as fast. So he's half the height, he's vertically flipped, and he's half the period. Half the height, vertically flipped, and half the period. And they kind of put stuff like that down below, I suppose. Shrunk horizontally by a factor of 2, so he's shrunk another half of the guy before. Shrunk vertically by a factor of 1/2. He's half his height, and he's reflected. So that one's a little messy. Sorry, it made you do 2 in 1 and then try to compare the 2 as to how they were related. Number 44 was hopefully a little bit nicer, though. 44 is a little bit nicer. Just one function. D is 0. There he is. Height, just 1. Up 1, down 1. Sine curve starts in the middle. No initial point shifting. The only difference is you have to finish in pi over 2, so quarter cycle is pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Middle, top, middle, bottom, middle. Is that okay? Not a lot of change. Sometimes the easy ones are hard because there's not a lot of stuff to identify. They wrote out the key points. Okay. 68, were you just putting it in your calculator? Nice. Just typing it in. No big dealio, hopefully. Anybody's calculator not working for them, or did we get it all working with the warm-up? We're okay? Calculator's okay? All right. Number 76. Number 76. Were you guys filling in stuff from a graph? Is that what you were doing? You were, right? Kind of like the one we did at the beginning of class? Okay. So here's the graph. Did you guys figure out the axis is -3? It's halfway between the top and the bottom. I don't like how they wrote this. I don't like how that's not going away. I don't know about you guys. I like it better when it's all nice and plugged in. So we're going to get y equals. So -3 is my sinusoidal axis. How high, how low? Doesn't it just go up 1, down 1? So 1. Did you guys choose a cosine? You might have tried to choose a sine. Cosine's actually a little bit nicer, and I'll show you why. Doesn't cosine start away from the middle? But wait a minute, if it starts from the bottom, what kind of cosine is that? It doesn't start at the top, it starts at the bottom. Oh wait, what could I do? I can make it negative instead. There we go. I could make it negative instead. I could have my cosine starting. Sine starts in the middle always, but cosine starts top or bottom if it's been reflected. To figure out how long does it take to complete. Well, if that's pi, this would be 2 pi, right? Isn't that normal? Doesn't cosine and sine, don't they normally finish in 2 pi? Therefore, it's normal. So I can just say, oh, x. And minus 0 because it didn't go anywhere. It's still on the axis. So technically it'd be 1 times x minus 0. And that's basically what they said. They put it kind of weird. They put it kind of weird. But that would be the final one. Now, you can also write this as negative cosine of x minus. I don't like writing it like that because you have to, okay, the minus 3 is outside. I kind of like the negative 3 in front. But sometimes they do write it like off to the other way. That's your d, whether it's here or whether it's here. Both ways, that's your d. And then 82 and 86 and 90. 82, you were graphing the two and you were finding the intersections. So you could, I think they actually gave you an equation, didn't they? Is that how that worked? Did they say when does cosine equal negative 1 or something like that?
y1 is cosine x, y2 is.
Oh, they literally gave you that. Oh, okay. I thought they gave you this and you were supposed to find when it's true in your calculator. It's the same thing. So y1 is 1, y2 is the other. They're asking, hey, when is it true? Find the intersections. And the intersections, this one would have been 3.141592. Ah, it's pi! And that one's negative pi. Because you guys can find intersections using what buttons in your calculator? Second, trace. Good. And you can find intersections. Some of you might have put decimals, but guess what? They're pi. But how do you do this in your calculator? Oh, x min, x max. You can put in negative 2 pi and 2 pi as your x min and your x max. Pre-cal graphing calculator handbook, how to set the window manually. Number 86, number 90. All right, let me freeze the screen to get the book up to get ready for your questions. Who has a question for me? I'm ready. Tony. 65. I'll take evens or odds. Anything else besides 65? Oh, Kyle, sorry, I didn't see your hand. 34. Anything else besides 65 and 34? 85? Okay. Starting with number 34, because that's the earlier one in the whole sequence. This one we did talk through, so I can't do the entire thing. You might want to check out the video over the weekend, but the long story short of what you wanted to do. The long story short of what you wanted to do, according to them. It says graph 2 periods. Now, the sad thing is my board is being weird, especially this window. I don't know why. Let me see if I can get it to actually work. Please be red. Oh, now it's red. Okay, well, whatever. They wanted you to graph this guy. Nice thing is I see him centered at 0. I see that he's going to go up 2. He's going to go down 2. He's going to complete. Here and here. Would do the work to get f of x. Then you're going to do the work to get g of x, and you're trying to put them on the exact same graph. This guy is up 1, down 1. He's not going to start up with the vertical reflection. He's going to start down. He's going to complete in 1/4 of 2 pi, which is pi over 2. So I actually need to cut that into fourths. And so he's going to do middle, top, middle, bottom. And so then they wanted you, after you did the work of getting both graphs, sorry, that's an ugly cosine. Then they wanted to say, hey, 2. Well, comparing the two, I see, let's see if I can change to one new color. Comparing the two, the blue one. So I can say g of x is, aka vertical shrink by a factor of 1/2 from that guy. He's half as high. I can see that he's reflected across the x-axis, reflection. This guy started up, that guy started down. They both have a sinusoidal axis of 0. They're both cosine curves. I don't say that that's what's different, but there's one more thing that's different. This guy took pi to complete, and this guy only took half pi. There's going to be, I don't like that. You can say horizontal shrink. So this one's a vertical shrink. Just comparing shrink, horizontal shrink, and then flip. Vertical shrink gets that. Horizontal shrink gets that, and then the flip. Yeah. Pass number 34. That's the short and sweet version. I know the book goes into more detail. I think, was it, I forget whose question it was. 61, is that right? Oh, 65. Sorry, wrong one. You're describing what happened to the parent function, the sequence of transformations from f to g, sketch function notation. Okay. So number 65, if I were to highlight it real quick. I don't like the way that's written, so I'm going to write it a little bit differently. Can't we write it as -3 plus 2? Do you guys like that better? The -3 goes in front. That's my D. 2 is my amplitude. Pull out the 4, which is my B, and then I get x minus c over b, pi over 4. Kyle?
So picking pi kind of like divisible by the even numbers. Like if it was like 6x, if it was 8x, and you took out 8, it would be pi over 8.
Mm-hmm. Because whenever you factor, yeah. Eventually, you're going to have to sketch the graph. So I would probably do it first, just because in my mind, it's like, well, I know what to do with sketching the graph. Going down 1, 2, 3, that's my middle. Going up 2 for my higher amplitude. Going down 2 for my lower amplitude. My initial point, pi over 4, but I would want to figure out my period first. So 2 pi over 4, which is going to be pi over 2. My quarter cycles are going to be pi's over 8s. So I'm going to go ahead and do pi over 8s as my units. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Now hold on, I have a phase shift right pi over 4. Signs go over pi over 8. Oh, okay, got it. It's not a negative, so I'm just going up the normal way. I could keep going, I could keep going. But they're asking me to compare that to the original sign. And the original sign would have gone up 1, and it would have, if I were to change colors real quick, would have started in the middle, my parent function. Started in the middle, just going up 1, down 1. It would have, well, did not mean to erase that. That's okay. I think that the one I just graphed has been horizontally shrunk, right? Pretty sure this guy's been horizontally shrunk. Pretty sure he's been shifted down. And I'm pretty sure he's been stretched. But couldn't the ABCD actually tell us that? Because over here I can say, oh, hey, he's been vertically shifted down 3. That's from my D. He's been vertically stretched 2. He's been horizontally shrunk by 1 over 4. Anything else? Oh, and he's been shifted right. Technically, the math tells you what happened. I mean, the graph does too. But he was shifted to the right. He was horizontally shrunk. I think I might have moved my axis kind of in the wrong way. That should have started there. Because sine starts in the middle. But anyway, there we go. Kyle.
If it would have been a 1/4, it would have been a horizontal stretch, right? The 4.
Yes. Yes. 1/4 would have been a horizontal stretch. I think I moved my axis to the wrong place, but that's the right idea. Is that my axis? Anyway. Things got disappearing, or started disappearing, which was confusing. And the last one was number 85. Oh, I like the ones like 85 because they give me words. They give me words. All you gotta do is use the words and plug into the formula. AKA it says cosine. Okay, cool. Okay, cool. I'm gonna plug into y equals d plus a. Hey, you guys finish this off. I've been talking all day. What's left? Of? Times? Who goes where? A is 1 because of what? Oh, it tells me that. Okay, A is 1. I know it's cosine because they told me cosine. What else? Left phase shift means x plus, because minus goes right, of pi. Vertical translation down, so -3/2. All I'm missing is p equals 2 pi over b. What hint do they give me? What does pi need to get divided by to be pi? Dun, 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 dun. I love those. Dun, dun. Okay, notes. Here we go. We've done really good on sines and cosines. If you need extra help, come on in and let me help you. But for right now, we need to keep going. All right, you guys go ahead and start taking notes. Graphs of other people. Graphs of other people. Let me pull down the title so you can see it. Who are the other people? I thought we did all the, sine and cosine is 2 of 6. We have tangent and cotangent, cosecant and secant. Did you get your question answered, Kim? Okay. Tangent and cotangent, secant and cosecant. I'm having you guys start off with a little baby unit circle. Little baby unit circle. Oh my goodness. Quizzes, you guys want to see how you did?
Yeah.
I'll pass them back in just 1 second. But for right now, I'm just putting the weird points. 1, 0, 0, 1, -1, 0, 0, -1. And I'm also putting a cheater chart for tangent. Because to graph tangent, we got to know some things about them. So the cheater chart, tangent of theta, had 0, pi over 6, pi over 4, pi over 3, pi over 2. Tangent is 0, square root of 3 over 3, 1 square root of 3, undefined. Okay. Well, there's some facts about tangent. Oh, sorry, Robbie. Whoops, whoops, whoops. No, it's my fault. I'm just dropping things. I think these are the highest scores I've had of a pre-class, their first unit circle quiz. I'm excited about that. But does not mean everybody did perfectly. The highest score possible was a 12 out of 10. And those of you that got a 12 out of 10, the question is, would you get a 12 out of 10 if I gave you one right now? My ones that got something other than a 12 out of 10. Oh, it's 12 out of 10. Didn't get written. Don't worry. In the grade book, it's out of 10.
Thank you.
You're welcome. My 12 out of 10s, would you still get it if I gave it right now? No warning whatsoever. My others, you need to analyze your mistake. What was your mistake? Here's how I gave points. Every single question was worth 2. 1 point was whether you got the positive or the negative correct. And on number 5, since it really wasn't a positive negative question, your options were either 0 or undefined if you were even close. If you put 0 and it was undefined, I gave you 1. If it was undefined and you put undefined, I gave you both, obviously. But number 5 wasn't really a positive negative question. It was on an axis. So number 5 was a little weird. But 1 through 4, I gave you 1 point for getting the right sign, positive or negative, and 1 point for getting the right number, numeric value, whether 1/2 or root 3 over 2 or root 3 or root 3 over 3 or root 2 over 2, whatever it was. The bonus, same thing. I gave you 1 point for the right sign because it indicated you were at least kind of in the right quadrant, and then 1 point for the right number. My question, would you still get 100 on this or whatever you got? Can you do at least as well if it's a surprise quiz, number 1, and number 2? If you missed anything, can you improve? What does that mean? There's another one coming. When? I don't know. Next week. Be ready. It's early next week. All right. Be ready. If you did well, can you do well again on a day that you don't know? And if you didn't do well, can you improve? If you have questions on it specifically, you can ask me right after class or during lunch or during period 7 or after school. Here we go. Just because we have to get going, Robbie. We have tangent. Who is tangent? Well, do you guys see how tangent goes to pi? You can ask questions after class or during nutrition or during lunch or after school. Yeah, keep them and then see if you made any mistakes. If you feel pretty good, lose that knowledge. Let's see how at pi over 2 tangent is undefined and more. Remember, a number over 0 is always a vertical asymptote. So as we come down here to our graph where we have thetas at pi over 2, this would be 3 pi over 2, which means 2 pi is way down here somewhere. At pi over 2, tangent has a vertical asymptote because he's undefined. He's a number over 0. If you want to think about it, tangent, who is sine over cosine, cosine has a 0 that cannot be factored out with sine because they're not zeros at the same time, as we can tell by the different points on the unit circle. When one is 0, the other is 1, and vice versa. When one is 0, the other is 1, and vice versa. So therefore, these cannot reduce like a whole would. There is a vertical asymptote, but not just at pi over 2. There's also a vertical asymptote at negative pi over 2. God was like, they need more time. Slow down. Okay. If you guys notice, tangent's going to be undefined at positive pi over 2 and at negative pi over 2. He's also going to be undefined at 3 pi over 2 and at negative 3 pi over 2. So then the question is, well, what's going on in between? Well, isn't tangent 0 at 0? Kind of like sine. Sine is 0 at 0. Tangent is 0 at 0. And then tangent goes up to root 3 over 3 at pi over 4, goes up to 1 at pi over, root 3 over 3 at pi over 6, up to 1 at pi over 4, 3, which is even higher. And if you guys keep on plugging in tangent values to your calculator, getting closer and closer to pi over 2, or closer and closer to 90 in your calculator, it's going to keep going up, 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 up. First quadrant, second quadrant. First quadrant, 0 to pi over 2. Tangent's positive. Fourth quadrant, tangent's doing the same thing, but negatively. Fourth quadrant, tangent's negative. First quadrant, tangent's positive. Second quadrant, tangent's negative. Third quadrant, tangent's positive. And now we have our tangent curve. Swoop day is very different swoop than exponential functions, very different swoop than ln, but a swoop nonetheless. Vertical asymptotes, where are they going to occur? They're going to occur when x, aka whatever is in the tangent, when x or whatever is in the tangent equals pi over 2 plus pi n. N is just a whole integer. We could do plus or minus pi n if that helps. Where n is equal to, quick reminder, 0, 1, 2, 3, 4, whole numbers, whole multiples of pi. So whatever's in the parenthesis for tangent, we're going to set equal to pi over 2 plus pi n. So I could go ahead and technically, if it helps, I could actually call this guy y equals tangent of u. And I could make this u equals, kind of like we do with domain problems, right? Kind of like we do with domain problems. So down here when we get to domain, we're actually going to use that vertical asymptote idea. Need a little bit of space for each of them. Periods for tangents are weird because they actually only repeat every pi. It only takes pi for a tangent curve to complete. So the period's just pi. It's half of the cosine sine one. Domain, my u's cannot equal those vertical asymptotes. They can be anybody else, but not those vertical asymptotes. The range, well, look at him. He goes forever low, forever high. Forever low, forever high. And symmetry, that's not even, that's odd. And we already know that because we know that tangent of negative x is equal to tangent of x from those even odd properties from section, I don't know, 4.321? I don't remember. We did the whole even odd. I think it was 4.1. So if I was to give you something like this guy, and said, oh man, tangent can get messed up, just like sine and cosine can. If I were to give you something like this guy, oh, tangent can get messed up, just like sine and cosine can. Let me just give you a few hints for tangent. Now guys, 4.6 has tangent and cotangent and secant and cosecant, so obviously we're not done today. However, some of you guys do have some extra time and you realize that Thanksgiving break is coming soon, so we're going to try to fit in as much as possible, and maybe you want to get ahead this weekend. To that end, I'm going to go ahead and post in Google Classroom underneath this homework that is not due until Wednesday, a couple videos from last year. And if you want to try to get ahead on how to graph tangent and cotangent and secant and cosecant, I won't say that's a bad idea. My advice is to go looking for vertical asymptotes first. Go ahead, you can pack up. Go looking for vertical asymptotes first. Find the period next, and then find the zeros last. And with all that information, you should be able, or you should be good to go. All right, cool kids, I'll see you later. Find the next. Bye, guys.